Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit zoals altijd met...
Hallo Ronald.
Jan Stomphorst, Solutions Architect bij ACC ICT. Hallo Jan.
Hallo Ronald. Hey, Cloud Native Day?
De Dutch Cloud Native Day.
De Dutch Cloud Native Day.
Ja. Heb je naar je zin?
Ja, het is echt ik moet zeggen, de talks zijn echt geweldig.
Ja.
Dat is we gaan best wel veel naar events. Maar hier zijn echt de talks wel...
Ja, een leuke variatie in de talks. Dus voor iedereen is er wel wat te vinden. Dus dat is super gaaf.
En ik heb iets gehoord over een tractor.
Een tractor. Ja? Vind je tractors leuk?
Ja.
Als kleine jongen, hè, naar de boerderij tractors kijken.
Maar we hebben wat gasten ook, hè, over een tractor.
Ja. So, without further ado, I'd like to introduce Wieneke Keller.
Yes.
Welkom Wieneke. En Sebastian Lenartowicz.
Hello.
To start with Wieneke, can you introduce yourself to the listeners?
Yeah, definitely. Yeah, my name is Wieneke Keller. I work for Aurea Imaging as their CTO. So I'm responsible for all the technology. And we built a nice device on top of a tractor.
Okay, and how did you get started in this project, or what's your background?
My background is I worked for many different companies, mainly as an IT architect. So I worked for Bol.com for a while, Access for All. Then I made a nice step into the broadcast for 2 years. So there I was responsible for more or less all the Dutch live television. But in the end, I really like innovation. I like hardware. So I really like the combination between data, hardware, innovation. And that's why I ended up at Aurea Imaging.
And where does the passion for IT come from?
Yeah, I think it's more or less that when I was young, I thought computers are kind of stupid. I'm going to make a better world and make computers.
Cool. Better,
cool.
Yeah. Nice. And Sebastian, can you introduce yourself?
Yeah, so I'm Sebastian. I'm the senior software engineer on the TreeScout project for the last year and a half or so, though I've been with Aurea for the last 3.5 years, originally from Canada, and now present here in the Netherlands for longer than I'd like to admit, given how bad my Dutch is.
What is your best Dutch word?
Not fit to repeat on air.
Okay, awesome.
Just make it super tough, right?
Yeah.
So I was originally brought into Aurea to help them build up their cloud infrastructure, transition from on-premises operation using basically Python scripts, because Aurea is started as a data science, is it really a data science company, geoanalytics company, towards building microservices in the cloud, building out their web backend, and then eventually brought it to the TreeScout project as a cloud native expert, software architect, software engineer.
Okay, and you've got a Commodore 64 shirt on, so I can tell you're going way back. So what's your background?
Not as far back as you'd think based on this shirt. I honestly came out of... I actually studied computer science at the biggest agricultural school in Canada, with a side of GIS, go figure. So Aurea, in that sense, is kind of the perfect fit. And then I came to the Netherlands, about 7 odd years ago for a different software job.
Okay. And you two had a talk here, the K3s on a tractor, a happy marriage. Can you elaborate on your talk? What is it about?
Yeah, what we did explain is the use case which we want to solve for our customers, the apple and pear growers in the Netherlands. And we explained how we want to help them, how we first did the first beta season, which did not lead to the results that we wanted to. Then how Kubernetes helped us to improve our solution. And then ended up into launching quite a successful product, which is now, we sell it in Europe, And we're growing quite fast as a company because we choose the nice architecture with Kubernetes.
Okay, and what was there before Kubernetes? How was the journey in that?
So the TreeScout started about 3 years ago, originally as a set of proof of concept scripts on a developer's laptop. Basically, can we take input from a stereo camera and use it to locate objects in the real world in sort of a messy outdoor setting? Turns out we could, so that started evolving into an actual all-in-one kind of turnkey software package mounted to the top of the tractor. The architecture ended up evolving. So last year, so beta season was spring of 2023. That was the first time we had sort of an all-up software and hardware package that we could actually put on a farmer's tractor and say, hey, go use it. The architecture we had at that point was effectively 4 pseudo microservices in a single Python monolith running inside a single Docker container on board the device. The problem with that was it was impossible to diagnose issues. Everything was dumping to the same log. Everything was talking to everything. If one component crashed, yes, it would come back, but it couldn't talk to any other components again. The result was we had, about 40 drives during that period, during that about week-long period, where we had the beta season. 6 of them were successful?
Yeah, 6.
And the average time for the farmer between actually driving his tractor through the field and actually getting anything useful out of that was about a month, which doesn't really work well when that entire season where that data is valuable lasts about a week.
Okay, and so the product scans the lens of the farmer to get crop information,
Yeah,
or
I can explain it maybe a little bit better. We were diving right into the
yeah,
details.
that's why I'm pulling a bit back.
Yeah,
so
no, that's perfectly fair. Yeah, so we're in the area of what calls precision agriculture, and we are in the apple and pear orchards, and we really want to get the best out of every tree for the grower. So the traditional approach is treating an orchard per field, and the field is somewhere around 1 hectare to 10 hectares. But then every tree get the same treatment. But a tree differs per...
yeah. It's a living being.
It's a living being, and it's standing there for 20 years. So it makes sense to see if you can optimize the output of every tree. And we're doing that by the TreeScout, and that's a device which you can put on the tractor, and then we're scanning every tree. And we share those results with the farmer, but we also make sure that he can take action on it. So one of the products which we also touched in the presentation is blossom thinning. So if you have lots of blossom on a tree, you get small apples. And small apples don't get a good value. You want to have mid-size apples because they're getting, you get the most money out.
You don't want big apples?
No, you want medium size.
That's a good tip for my apple tree at home. So if I have a lot of blossom and I want good apples, the blossom
you
away.
need to do blossom thinning. So what we're doing is our device can detect how much blossom is on a tree. And we can give a map with which tree has lots of blossom and not. And then the farmer can choose kind of a value where he said, okay, this is the optimum value for my apple trees. And then he can import that map into a sprayer. And then the sprayer goes on and off based on the map. So then you only...
The sprayer?
Yeah,
and
it's a sprayer. It's spraying kind of salty water. And if it's on the blossom,
a water gun
blossom will die. Yeah, kind of a water gun.
It's essentially a big trailer pulled behind the tractor that sprays various chemicals onto the trees.
Yeah.
But just like my water gun at home. So
only it weighs about 3 tons.
No.
yeah. Oh, that's awesome.
Yeah.
Yeah, what kind of tools do you use for this?
In what sense?
A tractor.
Yeah, the tractor. Yeah. What tools run on the tractor? Yeah.
So the tractor itself is basically just a tractor. Historically, so to run a precision sprayer, regardless of where the map comes from, you basically need 3 things. You need the tractor itself. You need a high precision GPS device known as an RTK GPS device, which is accurate to about 2 centimeters. Typical commercial GPS is about 2 meters accuracy, which isn't good enough for these kinds of applications since your tree is usually only about, in modern orchards, only about 50 centimeters wide. And then you need the sprayer itself, which is towed behind the tractor, loaded with chemicals, and then gets the feed from that GPS, combines it with that map that you plug in before you start, and then selectively sprays those trees.
Ah, okay. But there must be some also like a computer unit or like.
So the way agricultural peripherals work is actually each device has its own onboard computer. There is a tractor-wide communications bus. Basically, it's a derivative of CAN bus found in automotive applications, but each device is effectively completely independent. The only shared component is electrical power, a bit of networking, and a UI touchscreen.
Okay.
But each device basically drives an application on that UI touchscreen from its onboard computer.
Okay.
Yeah, and our TreeScout consists of cameras, onboard computer, and some communication with the GPS to get that feed.
Yeah. So, but I think because there's also a lot of machine learning, maybe there AI in the
onboard hours.
Tractor,
yes.
Yeah.
Well, not on board the tractor itself. Specifically, the TreeScout actually has two computers on board. It has a simpler one for communicating with the tractor-wide communications bus, as well as a ruggedized NVIDIA Jetson.
Yeah, exactly. That was the one I'm looking for. Yeah.
Yes, ruggedized NVIDIA Jetson with a whole pile of CPU, RAM, and storage to run the deep learning, cloud communications, hardware interfacing, all of that more complex stuff. And that ultimately is actually a single node Kubernetes cluster. That's why we're here.
Yay, Kubernetes!
Finally.
I was waiting for that.
Yeah, I
So
know.
my slides also started with becoming an apple grower in 5 minutes.
I still got a question about that also, but we'll get later.
But yes, ultimately our device is a single node Kubernetes cluster sitting on top of a tractor running a 7 or 8 service microservice architecture based largely on an internal event bus.
Okay, nice. So the Kubernetes part.
Yeah, and I would say, why single node?
Because that's the hardware configuration. Effectively, the hardware configuration was settled upon first. We have limitations on available power as well as physical package size, as well as what kind of hardware is actually available in the space. Ruggedized GPUs ruggedized GPU computers are very much a new thing.
Mm-hmm.
If you'd gone asking around for suitable hardware 3-4 years ago, you wouldn't have found anything. So the result is we need to keep power consumption relatively low because we're running off the tractor's 12-volt electrical bus.
Yeah.
We can't make it, this 2-ton behemoth sitting on top of the vehicle, both for space and safety reasons. So the result is it's a single. The overall physical package is about 60 centimeters long, 50 or 60 centimeters long, containing wiring harness, single ruggedized NVIDIA Jetson, and the other sort of simpler computer for talking to the tractor's own bus.
Okay, and why are you running then Kubernetes?
So where we started, like I said, was a single Docker container running a set of small services.
Mm-hmm.
What we found there was the services would crash. We had a watchdog service in that to restart them, but they couldn't reconnect to each other. We couldn't see what was going on. We couldn't diagnose issues effectively. Since we were already a Kubernetes company in our cloud infrastructure, it was a natural fit to also try and put that on the edge. So about a year and a half ago, we picked up K3s, saw how easy it was to install, and started breaking apart that monolith, written entirely in Python, by the way, into proper containerized microservices communicating largely over RabbitMQ.
And why K3s, not K8s?
Single node system and just easy turnkey solution. Bare metal Kubernetes, everybody knows, it's always been kind of painful. General recommended configuration is at least 3 nodes. K3s was a lot simpler to just pick up and go.
Oh, right. Oh, fair.
And you said deep learning. Are you running a deep learning application also on the K3s now?
Yes.
And is it then for identifying the tree?
Among other things, yes. So we have a number of applications on board, some deep learning based, some not. But one of the containers inside the Kubernetes cluster runs a full TensorRT pipeline, including hardware optimized models.
Oh, that's cool.
And we run that right now for the TensorRT models. We run that at about 10 frames per second.
Oh, that's really fast.
Mm-hmm.
And how do you deploy the new images?
So right now we're still working on fully automatic over-the-air updates. Where we are now is basically we SSH to the machine and change a Helm chart config. But we expect by about February to have fully automatic over-the-air updates.
Oh, nice.
Because
nice.
it's not so scalable right now.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
No, are you planning? Because if that node dies, there's no application anymore.
Correct.
Are you planning something more resilient, or?
We're not looking at hardware revisions at the moment. Thus far, we've not had issues with robustness. Though obviously that might change over the long term, given that the device lifespan is somewhere on the order of 7 to 10 years in practice.
Yeah, but I can also imagine you have like something like Argo CD running somewhere.
Yes. So that's actually where our automatic over-the-air updates are going is Argo plus OCM, because of course this is sitting on a farmer's tractor at the far end of a 4G connection. So this is actually why we opted against Flux, is because both stock Argo and Flux operate entirely on a push model. You can't have an agent-based solution, which means your downstream cluster needs to have a fixed IP address and be accessible over the internet at all times, which obviously isn't our case. We can't guarantee fixed IPs over 4G connection, so we added. That's why we chose Argo plus OCM, because that's the only, as far as I'm aware, only tool in this space that actually has sort of an agent mode,
Nice.
where it can where it can run based on a pull configuration. So then the device itself decides when it's going to receive an update, rather than the hub cluster trying to push an update to it.
Yeah.
Okay.
Yeah, awesome. And you started this year with this.
With Argo, yes. K3s we started about a year and a half ago, summer of 2023, basically after the initial beta season.
And are you doing something about security also? Or is it not a question in this?
So our threat, we've done some threat modeling. Our threat model's pretty basic, though, in that we're not harvesting anything that's sort of PII. And the data we gather isn't actually very valuable for a potential attacker. So our primary security threat is more along the lines of cryptojacking, botnetting, things like that. So more upstream supply side stuff.
Yeah.
So there we do take some precautions, but device security isn't a huge problem at the moment.
And you said this has to run for 5 to 7 years. That's really long.
Yes.
And really long for that hardware also.
Yes, that's so. One of the things we highlighted at the end of our talk for sort of next steps is K3s. Basically, we have to be able to update the whole system over that device lifespan. And an OS update, because it's a sealed box, an OS update basically requires a field technician visit. It's not something the farmer can do himself. So one of our design requirements is that we have to be able to update the full end-to-end package over the air, including all the in-cluster components, but also the host system, and also that little secondary computer, which is just a little embedded like old school EEPROM stuff, which we've recently gained the ability to do over the air as well.
Awesome.
Well, I can imagine a future where the farmer can have the option to do the maintenance themselves. When the node dies, he can just replace the hardware.
Effectively, yes. That's our dominant sort of maintenance model.
Yeah, but you have more nodes probably than. That's what the Chick-fil-A situation, right? They had more.
They had 3 nodes, yeah.
Nodes, and when the NUC died, they were in the situation of NUCs, and when the one NUC dies, they take the one out, pull the one in, it gets provisioned automatically, and they can go on.
And that's something I've seen in another place as well, at a talk at KubeCon Paris this year by some guys from Thales Aerosystems, the avionics company. They had something very similar. It was 5 blades basically in a shock-mounted box mounted somewhere in the airplane's avionics bay to run the in-flight entertainment system. And it was a 5-node Kubernetes cluster. If one node dies, send a tech out, swap it, away you go. The others take care of provisioning it and making sure it's actually joined the cluster. But yes, in our case, the hardware configuration was already decided prior to embarking on the Kubernetes journey, and that's the most expensive part to change. So it's not something we're addressing until we really have to.
Okay. What about telemetry? Is there what solution do you have there?
On our cloud side, it's Datadog. We're looking at Datadog for the edge side yet, but that's not something we've yet implemented. We're gathering a few basic metrics using application code at the moment.
Oh, okay. And I heard something from somebody here who went to your talk. You also talked about the situation in Italy.
Yes. So this year we had our second sort of all-up full customer test season back in beginning of April. Basically, weather got really good all across Europe, all at once in like the first week of April. So every single apple tree from Italy up to Germany was in bloom all at once.
Scaling.
Scaling, yeah.
Yes, exactly. Well, it's you talk
a challenging period.
you talk about seasonal businesses. Christmas rush ain't got nothing on agriculture.
Yeah, exactly.
So every tree was in bloom, so your cloud needed to scale.
Yep.
Yeah.
Awesomely.
Yep. The cloud side handled it fine. The problem we had, and this was the incident that you heard about, one of our developers, who shall remain nameless, except that I'm wearing his underwear, pushed a bug into our sort of primary camera interface code that caused the device to believe the cameras were upside down.
Oh, right.
Now, I'll give you a hint. In agriculture, the root of the tree is at the bottom.
Yeah. So it didn't see the blossom.
It did see the blossom.
Right.
It did see the blossom. The problem is it was placing it in the wrong place.
Right.
So all the
especially on the wrong side. Like it was switched the left and right, upside down. So it was kind of messy.
The actually generated maps were garbage, completely useless, and there was no way to salvage them. But because we had this microservice architecture, we were able to spot. As soon as the user reported the bug, we were able to find it, fix it, and push it out to his device within, I think, about 4 hours. And he redrove the field that afternoon and got good results.
Yeah, okay.
Yeah, I think especially that first season, it was more or less make sure that the product comes alive. It's quite hard to, from nothing, go to a product. So we decided to release it in a small batch with 8 customers and only release the bare minimum. So we didn't take care of over-the-air updates. It was just manual. We didn't have any release management. It was just if a software engineer was more or less brave enough to push an update.
Yeah.
And how many customers do you now have?
Yeah, we started with 8. We'll end the year with 25, and we're aiming for next year 50 more customers. Then we have 75.
So
mostly
And we are
across
now-
Europe, and next year the US and New Zealand as well as test
Trying
installations.
to keep it now more or less close to us, because especially the maintenance, it's good to that you can reach it within a day. And also the US, Sebastian was there this summer to do kind of a demo, and it was quite challenging to get everything up and running. But we already have contacts over there to also go to the US, so we're really international.
Interesting.
And try to enter each year more countries, as in the end the Netherlands is too small for to really grow.
And agriculture is a global business.
Yeah.
Just about every machinery supplier or equipment supplier does business across the entire world.
And your product works only with trees?
Yes.
At the moment, yes. As we talked about during the talk, one of the other things we're looking at for the coming year or two is making it more, making the hardware more flexible to support different camera angles and things, to support, for instance, field crops.
Yeah, would it be a thing also to make a mobile app so that the farmer can to pick up his phone and just walk around for a specific tree, or for maybe people at home who have like trees and want to do something with that?
New market.
Well, you need, there are 4,000 trees on 1 hectare. So if you really want to do precision farming per tree on your mobile phone.
Well, maybe there are special use cases for a specific apple cross, creating a new kanji apple or something,
Your phone also doesn't have high precision enough GPS.
Oh, right. Okay.
Commercial, civilian or sort of commercial civilian GPS, like I said, about 1 to 2 meters, which puts you 2 to 4 trees over.
Yeah, but I was just thinking about myself because I got an apple tree at home and I want to know how to get. I got always do the small apples, but now I know because there's too much blossom. But it's nice to have like that kind of thing.
Yeah.
I mean, at sort of the single tree level, you can thin the blossom by hand. That's been the traditional approach. Is you get a whole bunch of cheap labor and get them to cut blossoms off by hand.
Yeah.
The problem is that, of course, doesn't scale to commercial orchard size.
No.
That's where you get the sprayers. That's where you get the chemicals. But if you're applying them at the whole field level, you end up pushing some trees out of the green zone. Too few blossoms.
And I think one important thing is that we really want to integrate in the day-to-day life of a farmer. So he's going with his tractor through his orchard like 25 times a year. So if we can always collect data if he's driving through his orchard, we can really also help him in the future when we have like time series of data per tree. Then it becomes really interesting.
Yeah, that's awesome.
We can really see over years the results of of the treatment per tree. So we're now really focusing on like just getting value out of 1 year because we just started to selling that. But in the end, like probably next year we will also release yield estimation. So that we're going to detect apples and tell how much apples there are on a tree. And if you can relate for like the blossom thinning with the yield from the apples, then it gets more and more interesting. So on the long term, we will move more into that direction.
It's all about optimization.
And then a drone to pick apples.
They are already there.
Yeah.
Yeah, that's what the K3s guys were talking, or the Spectral Cloud guys were talking about.
Yeah.
No, actually, that was one of the question of the audience. And will the TreeScout become a drone? But actually, we started in the drone business.
Okay.
So this is for us the next step, and that's more or less because a drone is not integrated into day-to-day life of a grower. It's really kind of an.
Is it also not very difficult to maneuver a drone during an orchard with all the trees and the wind blowing through and everything?
Yeah, so you can be between the trees, so you need to be above them, and then it's quite hard to really see what's on the tree. So we were quite successful also with the blossom because you can see from the top how much blossom is on it, but it's just not as accurate and scalable as integrated really with the day-to-day business of a grower.
There's also certain agricultural practices that make drones impractical. Setting aside weather delays and things like that, many orchards now are installing hail netting, basically large areas of net canopy over the trees to protect them from hail.
Oh, yeah.
A drone can't see through that, which means you can't actually do any drone mapping.
And you've got also protection against frost and all that stuff.
Yeah.
That they do that with water, I think.
Yeah, that's right.
Yeah, so the end result is drones are good as kind of an entry-level thing, but there's a lot of problems with them, both operational and practical.
Funded, it's an entry level. It's the other way around.
The other way around. Well, we need to ask Spectral Cloud.
It's really like a drone you can just rent. You can just order. You can still order it at Aurea Imaging. Just a drone flight for one field, and then you can get experience with precision farming because precision farming is quite new. Many growers are just really first want to try it out before they invest in a TreeScout. So then it's quite a nice, a nice offer to also have.
Cool.
Yeah, very cool. Yeah. Up to we always have a final question. Sorry, we didn't prepare you guys for that, but it's not a very difficult one, I think. It's always how do you see the future of Kubernetes? Well, how would you like to see the future of Kubernetes?
So the obvious answer I can give based on the last couple of years is seeing how much the Kubernetes on Edge ecosystem is growing. So I attended KubeCon Amsterdam last year, and there were like 3 people talking about Kubernetes on Edge. Canonical was there with Micro-K3s. There was one talk about K3s. A couple people I talked to had a bit to say about it, but that was basically it. KubeCon Paris this year, I'd say a good quarter to a third of the talks were Edge related in some way. And here today, Spectral Cloud is here, of course. What was the other company's name? There was another company here also with a Edge offering, or like a Edge platform as a service offering. So I'm seeing that continuing to grow. Like, the Edge is the next frontier, and additional tooling growing in the Kubernetes ecosystem to meet the unique needs of the edge, especially the far edge, where you have things like network partition to worry about, semi-air gapping or complete air gapping. limited computational resources, things like that. One guy I talked to suggested the notion of a batteries included Kubernetes distribution, where it's not just a Kubernetes distribution, but it's also all of the other tools and operators you need to at least have a decent start.
That's a turnkey solution.
Effectively, yes. K3s is already kind of like that because you have K3s itself as well as the Helm operator, local storage operator, a couple other bits. But he was thinking a bit bigger than that. Install it. You've got everything you need to start building applications right there already.
Okay, cool.
Any additions?
Any additions? Yeah.
Not possible. No. I think from another angle, I think Aurea Imaging is also really a sustainable company to make the world a little bit better. And I just had also a nice talk about how can you measure the impact of Kubernetes on the environment. Mm-hmm. And I think that should be more relevant also with AI and all the data centers. So I think the future of Kubernetes is also to take that aspect into account. And not only on Kubernetes everywhere and the cool features, but also take care of the world.
Yeah, okay.
Cool.
Well, Thank you very much.
Thank you very much.
We're going to follow this technology close, and I hope to talk to you again in the future.
Thanks. Thanks for the invitation.
Given that it's a Kubernetes podcast, I hope you're going to follow it closely.
Of course.
We'll make sure of that.
Thank you.
See you later. Bye.
Thank you for having us.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k3spodcast.nl via Spotify, Apple en alle andere favoriete podcastproviders.